Hello, everyone. Welcome to our senior design project presentation. Our project is on the feasibility study of heat pump water heaters. Here is our team, Team Grid Life, and I'm the team lead. My name is Christian Sotelo. I'm a senior, and I'm a triple E major with a focus in power design.
Hello there, my name is Ben Haroman, and my major is Triple E in focusing on power.
Hello, my name is Brandon, and I'm a senior mechanical engineering major.
Hello, my name is Megan. I'm also triple E major with the focus on power.
Hello, viewers. My name is Randall Grill. Likewise, I'm an electrical engineer major with a focus in power.
Hi everyone, I'm Donald Arnold. I'm a senior in Triple E and my focus is on power systems.
That is our team, and as a team, we'll be working closely with the Sac State Sustainability Department as well as the faculties department.
With that being said, this is our executive summary for our project. Our team is going to conduct research that will cover the basis of replacing traditional gas water heaters with heat pump water heaters in commercial settings. Our new system will not only be around 2 to 3 times more efficient, but also have a positive impact on the environment as we're transitioning from natural gas to more sustainable means of heating. The study will be done through the analysis of ambient air temperature versus the power demanded by each heat pump water heater unit. We'll also be making the necessary infrastructure installations and design recommendations within reliability and compliance.
Thank you, Megan. And here is our problem statement. Due to increasing regulation in the energy sector, research on higher efficiency technology has become imminent. Implementation of heat pump water heaters will be crucial to the phasing out of fossil fuels and less sustainable heating systems. As natural gas becomes less abundant, other natural energy, such as heat generated from the sun, will forever be available. For our purposes, we'll be focusing the study on Riverview Hall, a dormitory building located on the Sacramento State campus. As shown in Figure 1, we believe this is an area of interest to focus our attention on. For example, in the months of January and February, we can see major natural gas usage at the hall, which negatively affects the environment.
Yes, and also a little bit more on Figure 1, we can see that during the months of January and February, we can see a total therm usage of over 120,000 therms of natural gas. This is equivalent to 634 metric tons of CO2 emissions for those months only. This reading also includes HVAC alongside water heating. Moreover, we can see that a very large amount of CO2 is being pumped into the air, and it is important that we reduce this number for better sustainability and reduction of carbon footprint. For our procedure, our problem will be analyzed and validated through the methods of thermal and fluid analysis on the heater to maximize thermal efficiency and reduce power usage and costs. This will include trying to increase the heater's coefficient of performance and efficiency factor.
At the same time, power system analysis will be conducted to understand how power usage with these heaters could save electricity by comparing our calculations to Riverview Hall's gas and electricity usage data throughout the recent years and seasonal periods. We'll also forecast potential electrical usage and loads for the heat pump water heaters.
So currently, Lochinvar has a heat pump water heater, and they show this graph here that you can look at figure number 2. We can see that this blue curve is means that as the air temperature, the ambient air temperature increases, we get more heat transfer in the heater, which is represented by the heating capacity in the BTUs. This will be important because at Riverview Hall, a maximum amount of BTUs needed is around 220,000 BTUs. So we're going to be designing for that amount of BTUs, and that graph shows kind of the relationship of the ambient air pressure, ambient air temperature, and the amount of BTUs being provided. From this graph, we can see that the lower the ambient air temperature is, the smaller the amount of heating capacity that we're getting. Meanwhile, as the higher the temperature goes, the more BTUs we're going to get. So during the summer seasons is mostly when this heat pump water heater is going to be operating at the best efficiency.
Figure 3 is a representation of the performance data of our specified heat pump water heaters, and I will be specifically talking about the amount of kilowatts being used at different temperatures. Looking at the data, we can see that when the heater is transferring the most heat, it is using the least amount of energy. And naturally, we expect to see a decrease in efficiency when air temperatures decrease in the colder months. This caveat will be a large part of our energy analysis in calculating the amount of energy being used at different temperatures throughout the year.
Thank you, Randall. So this will be our strategies. Our first part of our strategy will be conducting a research and design a commercial heat pump water heater for sufficient heating of Riverview Hall. Second part of our strategy will do also a research and design of the electrical requirements for the installation. Third part of our strategy will be do designs that must be within the NEC codes and local state mandates. Our fourth part of our strategy will be doing a comparison of the current gas water heater installations with our own electrical heat pump water heater design. Fifth part of our strategy will also do a comparison of our theoretical design with commercial heat pump water heaters that is already in the market. So I'll be transferred to Donald.
We're also going to be communicating with various vendors on the sizing, installation, and the part cost for the heat pump water heaters, as well as make various recommendations for possible ideal vendors for heat pump water heater models. We're also going to simulate energy costs and usage throughout a year for heat pump water heaters, both the theoretical design as well as our recommendation. We're also going to be observing the impacts on not only the environment, but the students' welfare with the heat pump water heater systems. For references, we were done so by the CSUS Sustainability Board, and one of our references as a Lachnevard, as shown below in the specification sheet.
Thank you, Donald, and thank you for your time. Thank you for watching and listening. Team Good Life out.